So remember our saying, like dissolves like. Polar things will dissolve polar things. Non-polar things will dissolve non-polar things. And let's just take a look at it. We can think about the solution forming as we could take a solvent and a solute. And we could think about it originally, right? All the solvent particles are touching one another. We're assuming, maybe like a solid inside of a liquid. And in order to make these two mix, the first thing we have to do is we have to break some of these intermolecular forces. And since we're breaking intermolecular forces, this is an endothermic process. So this delta H will be greater than 0. And same thing, we have to break these solute intermolecular forces as well. And so this is also going to require energy. Right, so then we've got our kind of particles far apart. Of course, this isn't how it really happens, but according to Hess's law, it doesn't really matter how it really happens as long as we're just looking at the overall system. And then when we combine the two, we can form some new intermolecular forces, right? Now we're going to form these solute-solvent intermolecular forces. Sometimes this is called solvation because the solvent particles are surrounding them, right? And so we're forming these intermolecular forces. And the same way when we form bonds, it releases energy. When we form intermolecular forces, that also releases energy. And so this delta H is less than 0. And so if we think about the total delta H's, the green delta H is going to be a negative, right? An exothermic process forming these solute-solvent intermolecular forces. And then the other delta H is breaking the solvent-solvent intermolecular forces and breaking the solute-solute intermolecular forces. Those will both require energy. And so the question is, when will mixing occur? Well, mixing will only occur when the total delta H, the sum of all these, is negative, right? Overall negative, exothermic, or slightly positive. And so you might be thinking, well, if it's slightly positive, it's an endothermic process. Shouldn't that kind of not happen? Well, that's not endothermic and exothermic aren't the whole picture. This still happens due to entropy. And again, you'll learn more about entropy in Chem 102. But the main point, if we take a look at these delta H's, this mixture is most likely going to happen when this delta H of these solute-solvent interactions is quite negative. And it's more negative the stronger the interactions are. So more negative with stronger solvent-solute intermolecular forces, right? And so that's the kind of explanation behind like dissolves like. And we can think about a bunch of different solutions. So we can think about like alcohol. In the common terms, it's beer, wine, liquor, whatever. Ethanol is like the actual alcoholic component, which is CH3CH2OH. And then it's dissolved in water. So like beer is mostly water, that kind of stuff. And then the reason that these two mix is because of this hydrogen bonding, right? This is a strong intermolecular force between the solvent and the solute, and it's what causes them to mix. When two liquids mix, they are said to be miscible. Right, and again, like dissolves like, so those two both have dipole-dipole and hydrogen bonding, so they are like one another, so they'll dissolve. If you think about other things like, like hexane, let's say, for example, and like benzene, right? Both of these only have London dispersion forces, so LDF and LDF, so they too will become miscible. And same thing with like two polar compounds, right? It's because of these strong solute-solvent intermolecular forces that they mix. Same with kind of ions, right? Ions will dissolve in polar compounds because of these ion-dipole interactions, which are strong intermolecular forces, which makes that delta H of the solvent-solute interactions quite negative, and so they become mixable. When things have very different polarities, then their solute-solvent interactions are very weak, and so they generally don't mix. So for example, water, H2O, very polar, has hydrogen bonding, and something like oil, which is basically just hydrocarbons. It's a little bit more complicated than that, but it's basically hydrocarbons. They won't mix, and instead they form two layers, where the more dense one goes on the bottom and the less dense one goes on top. When they don't mix, they are said to be immiscible.